So a small review session. I will preface this with it's 2 a.m. Well, 2:30 a.m. in the morning. I am a student and I am tired. So if I get anything wrong, I blame it on those two things. I came up with a brilliant question to what is this called? Machine code? Okay, assembly. Assembly, a beautiful assembly question. Okay. Whoever did the sound effect on the board, I ban you immediately. Who was that? Somebody tattle, please. Okay. I'll leave you with a warning currently, but like, come on. Okay. The destitution. Is this like a major issue? There's only the list. We need X. Okay, I'll make an XML for the page. Like this will only take me like 5 minutes. Swear. I swear. I'll get started. Assembly. The problem that came into my head was make a subroutine that uh takes a number or a yeah, sure, a number, whatever. Number located after the initial BSA and times it by let's okay, give me like a big number that's divisible by 2. 4? No, thank you, Carlos. Anybody else? Give me like a number that's like kind of relatively easy that's divisible by 4. Anybody? Anybody? 16, 16, 16. Or 12. Either way, let's just do 16. It doesn't matter. 16. Perfect. Times it by 16. Okay. You know, okay. So this is like, you see it and you're like, what the fuck? You're like, what is this question? But trust me, it is relatively simple. So I'm just going to do some pseudocode currently so you guys know what I'm talking about. But essentially, the solution is this. So you have a subroutine that basically, well, I can just start hex 0 or yeah, sure, hex 0, sure. You have a subroutine that once you call it, it wants to grab the initial number, which is after the BSA. So initially, since the number, we're gonna use a subroutine and we're gonna make it act as a pointer to a memory address because the BSA will call it. And then right after the BSA, you're gonna have the number that you want to multiply times 16. So you're gonna have like deck, let's say it's 0, 0, 1, for example. Okay. Sorry. Um, so you're gonna use a subroutine as a pointer. You're gonna okay. You're gonna store. You're gonna store the. Oh no. Actually, I think the professor covered this. You're gonna do ISZ sub. What this will do is, let's say this address is like 100, right? When you call the BSA, what is stored? Actually, no, we don't even need to do that. What is stored in the BSA is 101 because the PC always plus ones, right? So you don't need to do ISC. I want to do ISC because it teaches you something. So I'm gonna say, yeah, when it gets called, because the PC increments by 1 always, and it stores the pointer. It stores the PC. I'll explain. I'll go in more depth with it. I know. But I want to show it the hard way because maybe they need to know the hard way. Do you guys want the easy way or the hard way? I'll leave a vote. Easy or hard. There. Look, see democracy, guys. Can you imagine? There's no medium. I'm sorry. But vote now or nothing happens. But like Jesus. Okay, fair enough. Okay, so we want hard. Okay. So the hard part is okay. This is golden. Takes a number, not after. Takes a number located one PC, let's just say it, away from the initial BSA. So this is garbage. And this is actually the number that we want to grab. Let's just say it's whatever. Let's just say it's 0, 1, 0. Now it's 2. So when you call BSA, you store the current PC, which is always incremented, into the initial call, which is sub. So you would actually store 101 to the sub. But since this is 100, this is 101, and we're treating this as garbage, we want to get access to the next line in the code. How do we do that? We increment if 0. If 0. Or like increment if not 0. Or like skip is 0, but it increments. You know what I mean? Everybody knows what I mean. So I'm just going to go ahead. We're going to increment the sub. The sub is going to act as a pointer. Currently, the sub is it's pointing at 100. Right? If we increment sub, it now changes to 102. This is perfect because what is 102? Well, 102 is the number that we want to multiply by 16. Okay, so we increment sub. And then what do we need? We need to load the accumulator. Actually, we need to load the accumulator. Yeah. We need to load the accumulator with a number. Well, we have multiplied by 16, so we need to make a counter first. Multiplying by 16, that means you're multiplying by 2 how many times? 8. So now we need a counter that has -8. Okay, so we're gonna load to the accumulator. Let's just say we have just a random 8 that has value 8 in it. Well, whatever address in memory this is, or we can just do it indirectly. So let's pretend we have an 8 that stores the value 8 in decimal. Dec 8. We're gonna load 8 into this indirectly. So it accesses. No, we don't need it indirectly. We can just load 8, which has this. That's okay. Then we're gonna increment and CMA. This takes the 2's complement. What are we gonna do with this 2's complement? We're gonna store it in counter. So now pretend we have a counter that is at a random memory address. And now we're storing -8 there. I'm just putting -8. Usually you would just turn into you would do it in hexadecimal. I'm just doing it now because it's quick. Okay, now what do you need? You need a loop. What does this loop do? Well, this loop's gonna do the multiplication. First, we need to fetch the new number. We've already incremented the hex, so now it's pointing at 102. So we're gonna load the accumulator. Oh wait, first, a good thing to do in the loop is clear E. Because in order to multiply by 2, we need to do arithmetic, shift, left. So what's arithmetic shift left? Well, let's pretend we have an E here, and we have the the AC. In order to do arithmetic shift left, we need to ensure that this is 0 so that it shifts all these numbers up and everything works out. So we clear E, the first step of the loop. Then we load the accumulator with sub, but indirectly, so that we actually grab what is stored at 102, which is the number that we want. Okay, what else do we do? Okay, Now we perform the arithmetic shift left. Actually, or circular shift left, right? Because circular shift left plus clearing the E is basically arithmetic shift left. So we're going to perform circular shift left. Okay. And now what do? We say ISZ counter. So we're incrementing the counter. If the counter gets to 0, we want to skip the next line. So we want to set the next line to be the loop. So BUN loop, right? And then what's the next? Then let's do, after we skip, if we skip this next line, we want to exit through and we want to return the answer. And how should the answer be returned? Let's say you just put answer in AC, or put store answer somewhere. Sure. Okay, perfect. So in order to store the answer somewhere, well, now we have the answer in the AC after this, because this executes 8 times. Therefore, we do 2 times 8 times whatever the number is, which is number times 16. And all we have to do is store what's in the accumulator into an address. Let's pretend this address is just random. We're going to store it into this address. And then we want to bun. We want to bun back to the sub indirectly. And what this would do is that since bun does not return, basically this just sends the program back to the start. We take this address, which is 101. Maybe we increment and then we bun, sure. And then let's just say this is halt, sure. Okay, so before we take this last step, which is still correct, I'm just going to squeeze a little ISZ bun, no, ISZ sub. So sub now points at halt, because now we incremented by 1. Before it was pointing at 102, now it's pointing at 103. And then we do the last thing, which is bun sub indirectly. And this exits the program. And that's pretty much it. That's your code. So to summarize quickly, basically, we ask their random question, make a subroutine that takes a number after, okay, one PC increment away from the initial BSA and times it by 16. You take that value, you make the sub, you go through my solution, and your answer will be multiplied by 16, because you would clear the AC and then circular shift left, clear the AC, circular shift left, until the counter reaches 0. When it does, it skips, it stores whatever value you get, and you are done. Does anybody have any corrections? Does anybody think that this solution is false? Speak now or like forever hold your peace. Yes, exactly. I'm failing, Habibi Yameshu. Have faith. The easy one is like this is not too hard, guys. This is like, look. It's okay. It's okay, guys. Don't argue. What don't you understand? What don't you understand? Okay. Look. I'm gonna probably post this one to YouTube. Okay? So if you don't understand, let me know so you help the YouTube people out. Okay, they want the easy one. Well, the easy one was not really that easy. It would literally just eliminate one line of the hexadecimal. Uh I'll show you exactly which line it deletes. So pretend that you have the same question, but instead, you make a subroutine that takes a number after, not one PC away, just after the initial BSA. So basically, the number that you want to use, this is not garbage. You want to take this number and multiply it by 16, this one up here. You would just delete this line because then it would already point to 101. And that's it. That's like your so-called easy thing. Assuming that this does not exist already. Anyways, okay. Are we done with this session? I feel like yeah. Oh yeah, for sure, for sure. Here, I'll even rewrite it. I'll show you how easy it is, okay? Look, no looking at the code. Okay? This is like off the top. I'll just do the BSA part. Trust me, I got this, okay? Please, I don't want to take too long because the YouTube video will be long, but let's just see. Okay, we're gonna have a subroutine. Look, I'll get on that. I swear. Okay, we're loading to accumulator. Listen up, okay? Everybody, mute, okay? This is gonna be my last go through. Perfect. In the sub, we just put a random variable because it's always just gonna be overridden. It doesn't matter what you put in here, it's gonna be overridden. Because once you call BSA sub, well, the PC's next address is gonna be stored in this spot. Okay, I'm gonna also repeat, please mute if you're a new joiner. Okay, your next step, you want to, first of all, we're gonna assume that the number that we want to times by 16 is the next address after the BSA. So I'm gonna ISZ sub. This basically increments zub, and then skips if 0. Sub will never be 0 because it's always gonna be PC plus 1, right? PC plus 1, 0 plus 1, never 0. You're never going to have a negative memory address. At least we haven't covered that so far. So therefore, this actually we don't even need ISC sub. Never mind, because we're doing the easy question this time. So we just take the sub, but we need to make a counter, which will help with the loop that will come sooner or later. What does the counter need? Well, we know that circular shift plus clearing E, CLE, is arithmetic shift right. Shift right. And we know from previous midterm that arithmetic shift right multiplies the binary number by 2, or any number by 2. So we need to multiply it by 16. That means we're multiplying by 2 8 times. So we need a counter that is -8, because the only way we can skip is if it's 0. That's why we need to make it negative. So I'm going to pretend that we have a decimal value. What? It doesn't multiply by 2, but it shifts it. No, I know I'm doing a loop, bro. You didn't pay attention. Just trust. Oh, wait, you think I'm doing the power to the power of 8? Oh, you're actually right. Yeah, you're actually right. No, fair. Okay, let's just change the question. Let's pull a nice move, and let's just do. You can. That's one of the questions actually, but I kind of wanted to do it. I guess you could do that, but to be honest, well, okay. I literally asked yo, is my implementation wrong? Like 4 minutes before, and nobody responded. I'll put that out there. Look, I'll help you fix it in a minute, okay? Let's pretend we're doing 2 to the 8, okay? And I'm actually not going to go through the resolution again. I'm just going to go back up to the top because I do have to help the situation. So let's change this. Pretend this is 2 to the 8, which, you know what? It's actually just a better problem. I'll just say it's like more impressive, personally. If you're doing 2 times 8, it's the same problem that the professor went over in class. I want to do something different than what he went over in class. So if there's hiccups, it is 2:44 in the morning. So I blame it on that. But this is essentially the solution. There will be a recording. You can just rewatch it to kind of find out what I did. But it's very simple. You make your counter. You store the counter, which is right here. Then you make a loop which does the 2 to the power. And then you store it right after the counter is equal to 0. And that's pretty much it. And then you button to the start, back to the main program where you halt. Done. Okay. Thank you guys. That is all. I am going to bed. Take care. No, I'm helping you. I'm gonna help you for sure, for sure. I just say I'm going to bed to yeah. Anyways, time to work until maybe 3. Bye bye.